5.7 is the last set of notes for Unit 5. Unit 5, we started off with talking about a whole bunch of things like different polygons and stuff. And then we went into these quadrilaterals and we started really figuring out what's what. We started figuring out what's a parallelogram, what's a rectangle, what's a square, and we started doing problems with that. In 5.7, we're going to have to do some things where we figure out whether an object is something based off of variables. And the whole reason they do this is so that it will work for anything. Instead of just dealing with numbers and lengths, why not do it in terms of a variable, and then it will apply to every type of shape that works like that. So what you need to know when you're doing this worksheet is this is what the basis of advanced mathematics is. It's because you're doing things in terms of a variable instead of numbers. That way it applies to every shape instead of just the one shape that you're looking at. You can only use the variables that are given. Do not invent your own variable. Do not make up your own letter. If it starts with the letter B, then use the letter B. The only thing that you can add, but you can add a 0 as needed. Okay? So if you need to add a 0 because we're talking about an x-intercept or a y-intercept, that is okay. You just cannot add any new variables. All right, with that being said, do not forget that your horizontal distance is, I usually say x, but they don't always use x. They might use an a or a b. If it's left and right, that is the first letter. If it's up or down, that is the second letter. Vertical means up or down, horizontal means left and right. If it's horizontally touching the axis, don't forget the 0 is in the second coordinate, that your variable would be here. If it's a vertical intercept, then the 0 is in the first coordinate. Those are the things that you're going to have trouble with or that you need to remember. So let's do some examples. I actually have several examples picked out. I should have passed that worksheet out to you. You guys have it already, yes? Yeah. Okay. So I have picked out 2, 5, 10, and 14. Let's look at number 2 together. The directions for number 2 say, what are the coordinates of the vertices of each figure? This is a rectangle centered at the origin with base of 2b and a height of 2h. What that means is this base down here from here to here is a distance of 2b. Well, if that's the distance of 2b, then what that means is that the length is going to be half going to the positive side and half going to the negative side. If the full length is 2b, then the distance going in the horizontal direction has to be b units to the right, and the other half is going in the negative direction. So over here, this is going to be negative b units to the left. Distance is always positive. The negative just represents the direction. Even though these are negative distances, like it's not a negative distance, it's negative in the direction. That's 1b, here's another b, that makes 2b. I hope that makes sense. That's how I can explain it best. The height is 2h. From here to here is 2h. But half of it's going in the positive direction, and the other half is going in the negative direction. So if I cut this in half, 2h divided by 2, that means I'm going up h units in the positive direction, and I'm going down negative h in the negative direction. You have 1h below the x-axis, and you have 1h above, and 1h and another h makes 2h for your distance. That is why I get these distances. And now what they're asking me for is what is the letter D at? What location? And I know that the left distance going to the left is a negative b distance, and going up, I'm going h units up. This is at negative b, comma, h. That's my answer. My answer is left b units, up h units. So if you are trying to do E, you're going to the right and up. I'm hoping you know what your two letters are. What's the first letter? I agree. The second letter? I agree. You went to the right, B units. You went up, H units. That's it. The hardest part was figuring out that if you have 2B, you have half to the right and half to the left, and I wrote those right there. Now let's do F. Here's F. I have to go to the X direction first, then the Y direction. X direction, I went how far? I went B units. Then I went in the Y direction down H units. It's negative H. B, comma, negative H. And G is at negative B, negative H. I hope that makes sense to you. It does to me. And that's how almost all of our problems are going to be. The first three problems are just like this. Number 5. Determine the missing coordinates in the diagram. Do not introduce any new variables. All we know is this location right here. This corner is at D, comma, R. That's it. That's all they give you. Well, what you should know is to find this, the horizontal distance is the same thing as this distance. This is your horizontal distance. D is. So that means that this point right here has the same horizontal distance. It should be the letter D. How far up did we go? We went, this is an x-intercept. If I think about this point is at 0, 0. We can use zeros. That's okay. We just don't want to introduce any new variables. How far up did we go? We went 0 units up. It's the same for an x-intercept. If this is an x-intercept, we can put a 0 for the second blank. We're using the horizontal distance, and we're saying that we went 0 units up. That's okay to write down. Let's go over here to this corner, top left. I went 0 units left and right. And how far up did I go? Since I went up a vertical distance, that's the second letter. The second letter vertical is R. And so what you're going to be doing during this whole worksheet is putting in like a 0, comma R, D, comma 0, 0, 0, and you're filling in the gaps using that information. Any questions about that? So then I decided, let me pick one that's a little bit harder. Something that they're going to have to know something about a parallelogram in order to be able to answer. They give you this point, they give you this point, but they ask for this other point that's out here. The vertical distance is easy to figure out because I know that the vertical distance from here to here is the same as it is from here to here. And it's going to be the same as it is from here to here. We went up how far, how far, how far did we go? And we know this point. How far up did we go? Vertical distance, we use the second letter, K. That must mean that this second letter has to be K units up. Now the hard part is this first horizontal distance. So what I'm going to do is I'm going to take this parallelogram and I'm going to go, okay, I went this far to get to this point. I went this many units, and it's in terms of a variable. This variable is g. I went g units from left to right. Well, if that's the case, and that's g units, and this is a parallelogram, the opposite sides are congruent. So if I went g units here, then I have to go up here, and I could say that this has to be g units. But how far did we go to get to this corner? From here to here, we went horizontally c units. I went c units to get to there. I have g units there, and a c and g. So this corner has to be what for my horizontal distance? It has to be c plus g. The hardest one by far is number 10 because of that. Because you have to go, oh, it's g units plus that c units to get to that horizontal distance, but the vertical distance stays the same. You understand that, then all those other problems on 4 through 12 will be easy for you. Last example is number 14. Number 14 says, quadrilateral FLEA is a parallelogram. Find the coordinates for points F and E. So we need to figure out where E is, and we need to figure out where F is. What I do know about A is that we went over in the negative direction n units. So I'm going to put that this is n units. That's the distance. Distance is always a positive value, even though we're going in the negative direction. That's n units. I know that this corner is n plus m, so I'm going to do this. Since I know that this distance of this part of the triangle, I'm going to draw a little dotted line here. Because I know this distance is going to match this distance, I know that this is about n units from here to there. Has to be n units. And I notice that this point L has n plus m. I bet you I know how far this is now because I know what this coordinate is at. What does this distance have to be? I agree. Which is going to help me figure out what E is at. If this distance is m, and I'm going from here, then this must mean that I'm going horizontally m units, and I'm going up 0 units. This has to be m comma 0 for E. For F, I went 0 left and right. I'm just going straight up. I went 0 units left and right. When I went up vertically. How many units? I can use this distance there. That's the distance I went up. It's the letter P. I have to do it in terms of those letters. So this is at 0 P. Now what you're going to do for part A, part B, and part C, once you get those things down, is you're going to show that the opposite sides are parallel. This is the hardest part. It's why I chose these problems. How do I show that the opposite sides are parallel? Well, if I want to find the slope of AF, I have to do y2 minus y1 over x2 minus x1. There's my formula. How do you do that with the variables? It's very easy. You take the second y. Get ready. It's going to get more confusing. It's okay. y2 minus y1 is p minus 0 over x2, 0 minus the negative n over x1. We're doing this in terms of variables. That way it works for everything. This is called a coordinate proof. I bet you know what p take away 0 is. It's just p. I bet you know what 0 take away a negative n is. When you have a minus a negative, it's the opposite of a negative. It turns into a positive. Guess what your slope is? Your slope is up p over n. I know that's random. I know that looks crazy, but guess what? Now we can do the other side. What's the slope of EL? We do y2, p, minus y1, 0, over x2, n plus m, minus x1, m. And we're going to simplify that. What is p take away 0? P. N plus m minus m. Look at what happens with positive m and negative m. They cancel out. What does that make? Our slope is p over n. Now, the big idea behind this is look at the slope of this one is p over n, and the slope of this one is p over n. What does that tell you? The slopes are the same. What else does that tell you? It tells you that they are parallel to each other. Now you know that they're parallel, that these two sides are parallel. If that's what you did here, then you should be doing the same thing for FL and for AE. I'm not going to do those two with you. You should be able to do those on your own. If you need help with it, I will help you individually. But that's what you're supposed to be able to do. Let's do part B. Show the opposite sides are congruent using the distance formula. x2 minus x1 squared plus y2 minus y1 squared. That's our formula. Now, how does that work? That works the exact same way, except we have to subtract our x's, put it in parentheses squared, and we have to subtract our y's, put it in parentheses squared. So let's look at that. I want to do, let's do the distance of FA again. I'm going to do 0 take away negative n squared. I'm going to do that first. Those are my x's, subtracting. Then I'm going to do my y's, plus y minus the other y squared. What does that look like? That looks like we go 0 plus n is n squared, plus p minus 0 is p squared. When you get to here, this is how long FA is. You cannot square root anything else. This is as far as you can go. We're going to do the same thing for LE. How long is LE? Let's find LE's distance. What I do first, I take my first x and I subtract my second x. Square it. I take my first y, I subtract my second y, put it in parentheses, square it. And then what we do is we simplify this. And when you simplify it, what the amazing thing that happens is that for FA's distance, you have the square root of n squared plus p squared, and for LE's distance, you have the square root of n squared plus p squared. What does that look like? They are the same. It works for variables. It's going to work for numbers. Mathematically, you have now proven that these two distances are the same. This is high-level stuff. This is what deeper mathematics does all the time. For those of you who want to go past Math 3, this is what you kind of stuff you kind of do. If this is the hardest stuff in this unit. You won't have to do a lot of this, by the way. Just so you know. If you can do the whole parallelogram parallel thing, that's fine. This is probably a little deeper than what you guys all need in this class, just so you know. But I do like exposing it to you because it's good for you to know what other levels are doing. And then the last one, diagonals bisecting each other. You're going to do the same thing with midpoints. You're going to use the midpoint formulas. You're going to find the average of your x's, and you're going to find the average of your y's. If those two midpoints are the same, then you know the diagonals bisect each other. Meaning, if I find the midpoint of this diagonal, and I find the midpoint of this diagonal, those two things should end up being exactly the same, just like we did for part A and for part B. I'm going to stop your notes right there.